Welcome to the first math video of this channel. First, I would like to clarify that this video is not meant for beginners. In this video, we'll be looking at a concept called functions. Functions can be defined as a set of answers for a set of questions. Let us start by finding out some properties of functions. Functions have two sections to them, a domain and a range. This is a diagram of a function. It is not a complete diagram, but we will draw a complete diagram from this. This is our domain, while this is our range. Range is our answer, in other words, our output. Domain is our question, say input. It is our input. Let me tell you what this function is. This function can be written as f of x equals x squared. F represents that this is a function. Your x over here is your input, and x square is your output, which is basically your range, right? This is how a function is written, and this is how a function is represented in a diagram. Now, let us start putting each of these values as x and find out our range. F of 1 equals 1 squared, so we will match 1 to 1. F of 2 equals 2 squared, that's gonna take us to 4. F of 3 is 3 squared, 9, 4 squared, 16, 5 squared, 25, 6 squared, 36, and 7 squared, 49. This is our function. This is how a function is mapped. You draw a line between the input value to the appropriate output value. This relationship is called a one-to-one relationship. A function must have a one-to-one relationship, at least a one-to-one relationship. That means all elements need to be mapped to one element. All elements of the domain, which is our input, need to be mapped to one element in range, and only one element. To only one element. Let us take a look at another example. This is a completely different function. Do you notice the difference between the previous function and this function? In this function, if you noticed, you can see that B, A and E both are mapped to E. A and E both are mapped to 2, a domain. A and E from domain is mapped to 2 from range. In this example, One element in the domain is only mapped to one element in the range, and there is no repetition. All elements are mapped to different elements. But over here, two elements are mapped to one element in the range. This is called a many-to-one relationship. A many-to-one relationship. These are also functions. Many-to-one relationships can be functions. Over here we specified that one element in the domain needs to be mapped to one and only one element. But didn't say that various elements in the domain can't be mapped to one element in the range. Different elements in domain can be mapped to one element in the range. So this is an accepted type of the function. We need to have at least a one-to-one relationship, or we can have a many-to-one relationship. Second. Let us look at another function. What difference do you notice in this function? Think about it for a minute. Domain D is not mapped to anything. Everything else is mapped, but it's not mapped. But domain D is not mapped. Do you think this is a function? Go through this. This clearly mentions that it needs to be mapped to one element and only one element. It needs to be mapped to one element. But over here, D is not mapped to one element. That tells us this is not a function. This cannot be a function. So, we now know that all elements need to be mapped to one element. Let us look at another function, one last one. The domain is here and the range is here. What do you notice different here? D. Our element D over here is mapped to two elements, 2 and 7. Is this accepted? You're right. No, it's not accepted. Not a function. One element in the domain cannot be mapped to more than one element in the range. We have clearly mentioned that here. And only map to only one element. Map to only one element. That's very important. So these kind of examples are not a function. This relationship over here, we can also call it one to many relationships. One to many relationships are not accepted in functions. So let us write down. For something to be a function, or rather for a relationship to be a function, for a relationship to be a function, number one, it needs to be all elements in the domain needs to be mapped to only one element in the range. All elements in the domain needs to be mapped to at least one element to only one element in the range. Not more than one, not less than one. One to many relationship not accepted. Not accepted. Now that we have discussed on how to identify if something is a function or not, let's look at more of such functions. A written function. Let's take a look at an example. That would be f of x equals 2x. F of x equals 2x. As we discussed previously, our f is a function, represents a function, x is our input, and 2x is our output, basically our range. Now, we discussed two parts of a function, right? A domain and a range. In these examples, we already see a domain and we already see a range. If you ask me what's a domain, I'll just say 1, 2, 3, 4, 5, 6, and 7. Over here, we don't know what's the domain and the range. We have to identify it from this written equation. Domain is a set of inputs and a range is a set of outputs. So we need to think what all values can be multiplied by 2. A better way to do this is to think what values cannot be multiplied by 2. Are there any values that can't be multiplied by 2? No, I don't think so. So we will be writing x belongs to R. This symbol means belongs to Rx represents input and R represents real numbers. Real numbers are basically all our numbers, our decimal, rational numbers, irrational numbers, fractions, integers, everything. Our range over here is represented by Y. Output. Our output, what can it be? What will be our range? Since all our inputs can be everything, so as it's real numbers, our output can also be everything. If there are no restrictions in our domain, there are no restrictions in our range. Y belongs to R. That means our range belongs to real numbers, all numbers. Let us take a look at another example. F of x equals square root x. Try pausing the video and try identifying the domain and the range yourself. I'll give you a minute. Welcome back. Let's try to identify the domain and range together. The domain. What are values that can't have a square root value? What are the restrictions for the domain basically? They are negative numbers. What is this? Square root of -3. These values give you imaginary numbers. The, the key word is right here, imaginary numbers. They don't exist. They're not part of real numbers. Imaginary numbers are not actual numbers. Square root of any negative value gives you an imaginary number. Other than negative numbers, now that we know negative numbers cannot be part of our domain, what are the other numbers? Positive. We can put 1 by 2, 0.053, anything. And we can also put square root 0, which will just give us 0. So, we can now say that x is greater than or equal to 0. If you don't know what the sign is, it's just this. This is the greater than sign. Greater than. This is the equal to sign. Both of them put together, you'll write it like this. Now, if our inputs can only be 0 or above, what will be our output? Our output will also be 0 or above because our first value in the domain is 0. Square root 0 is 0. After that, all the infinite number of numbers, and they can all be part of the domain. And all those numbers starts with 0, the domain, so range will start with 0, go on from 0. So y greater than or equal to 0 will be our range. Let's look at one last function before ending this video. F of x equals 1 by x plus 2. The domain, and here we'll have a range. What do you think will be the domain? How about you try doing 1 by 0, 5 by 0, 3 by 0. Put these values in a calculator. All these values are going to give you one answer. Undefined. Any number divided by 0 is going to give you undefined. This is not a value. So we cannot have x as 0. Then you can't add 2 to undefined, right? So that's just going to give you an error. So we can't have x as 0. So we are going to say x not equal to 0. This symbol means not equal. You put an equal to 1, then you put a slash on it. A range. If all our inputs, if our inputs can be anything except 0, what will be the restriction in our output? You may have guessed this, but our range will not equal to 2 because you're adding 2 to it. Only 0 plus 2 can give you 2. Nothing else can give you 2. 1 plus 2 gives you 3. Minus 2 plus 2 gives you 0. Only 0 plus 2 can give you 2. Are there any x values that you can put which can be divided by 1 and will give you 0? No, not a single value. Only if you get output as 0, you can add it to 2 and get 2. But you can't keep the x value as 0, as that's undefined. So we cannot get our output as 2. We can't have our output 2. I don't know why I put a 0 here. It's 2, not 0. Y not equal to 2. This is all for this video. In this video, we looked at how to determine if something is a function and how to find the domain and range of different functions. This is going to be a series, as functions is a huge topic and has various elements to it. So I'll be posting more videos as a continuation to this concept. Thank you so much for watching. Subscribe to our channel, like the video, and comment down your thoughts about the video.